points, maths, even in many cases we have physics, chemistry, maths, physics, chemistry, biology, maths, but somewhere down the line we have all these combinations coming that we apply in some practical situation. And when we find that, say whether you consider about mechanical engineering, whether you consider civil engineering, so when we find these disciplines, at every point we have this measurement as a concept very important to be studied, and it gives us the importance of some kind of checking, testing, reliability, all these factors. মানে তুমি কোন একটা মেকানিক্যালের কিছু টেস্ট করছো, মানে if you are not, your design is not approving the fail safe model, then you cannot put it in the market. মানে you cannot go for batch processing. মানে একটা মডেল তৈরি হবে, তো যারা তোমরা মেকানিক্যালে আছো, if those of you are going into say like industries like Tata Motors or any other automobile sector also, you will find, at least I have seen for my friends when we have graduated say long time back in 2005, so mostly when they were going to the industry, when they are producing something, the first model was very important, that what you are producing with all the parameters considered. So when that first model is produced, then what happens? All the different copies of the model that is coming out into the market, they are produced exactly from the same replica of the model that has been prepared. So let me just give you one very important aspect. Like I have Ford Figo, which was maybe during 2011 I had purchased that. So within a year or so, Ford had recalled all the vehicles which have been sold in that particular phase because there was a problem in the gear system. In the gearbox there was a particular problem, and it has been identified maybe for 2 or 3 different varieties of the car produced in that phase. So they had immediately called for all the maybe lakhs of cars sold during that phase, and they have asked that part to be replaced without any cost because there is a chance of any failure. But somewhere down the line I was not facing any difficulty, or whether maybe that there was no problem from my end. It may so happen that I am not using to that extent, or maybe it has not suffered that problem which has been detected in some of the cases. Tale what happened? The entire phase in that batch processed segment, entire phase they took it back, they replaced it, and you all know this. This is true for not only automobile sector, this is true for any case of maybe the processors that we are using. If you are using a laptop, suppose you are using Core i3 processor, Core i5 processor, anything like that, and when you have these different kind of problems, you will find that someone says in this particular processor, in this particular generation there is a problem of heating. You will immediately find that the next generation is coming up for the same processor where this particular problem has been recovered. When we talk about the software also, we find that some of the cases, starting from the operating system to any particular software, we have the beta version, then the final versions, and then when you have the new patches coming, new updates coming, what it does, it takes feedback from the people who are using it, and based on the different errors which have been generated, people are trying to modify those components, and they are trying to pass on a patch or an update on that particular software so that those errors can be rectified. In many cases we have come across situations that I am not facing any problem, why should I update? You will find that this happens with our Android phones or any of the smartphones that we are using from Apple or anything. You will find that from the Play Store they are going to ask you to update. In many cases when it comes to the banking sector, you will find this is very treated as emergency. You are not allowed to log into the different net banking portals through your mobile banking apps. They will ask you to update because maybe they have incorporated some security features into that probably there was some breach of contract somewhere that has been reported, so they have increased that security point of view at some level. So they want all the customers to update the application accordingly. So we find that whatever the system, whatever the engineering discipline you are working with, whether you are talking about hardware, whether you are talking about software, everywhere there is a continuous process of analysis, continuous process of measurement of all the parameters at every level, and depending on the different situations, depending on the different critical points, those are analyzed. It is always a fact that every individual is not going up to the threshold level of utilization of any hardware or software. Say for example, out of the say 37 of you who are present right now, some of you are into the segment of say video processing or something like that. You are editing videos like that. So you will observe that if you are trying to edit videos, if you are trying to edit long videos or HD quality videos of say 1 hour or maybe even 15 minutes, 20 minutes like that, you will observe that your laptop is, whatever the processor you have, it is not able to tackle that enormous pressure that is created when you are trying to process the video. So it demands more processor speed, more RAM speed, maybe a lot of other factors, and it produces lot of heat. So many things are there. So we find that those who are into these video processing or image processing sectors, they demand the desktop machines, maybe in an environment where you have a very high AC working. So lot of issues are there which needs to be given as an addition to support the hardware that you are using. So even if we say that I have a 16 GB RAM, I have this kind of a hard disk or the hardware support, but definitely there is a threshold of utilization of those kind of situations, those kind of hardware with respect to the applications that we are working with. So when we take up all these situations, we need to know what are the threshold levels, what are the basic analysis aspects, and how can we measure different parameters. Or rather, even before measuring the different parameters, we should know what are the different parameters that we need to look for. So in this aspect, this entire course is structured. So when we start, when we refer this as electronic measurement, for many other disciplines you will probably say that's an electronic measurement we are only mentioning, but when we talk about different books, we find that electrical measurement, some mechanical measurement, many other different terms are used with reference to the factors. So how we will try to focus in this aspect. So before I start, two things that I would like to again highlight here. Let me share. Right, can you see the screen?
Yes, sir.
Okay.
Yes, sir.
Zora.
Say when we are trying to refer to the terms like electronics, electrical, this is a very common starting point what I mostly do for very specific courses. So maybe my electronics department students, they have come across this mode of teaching that I am doing right now. So when we come across these terms, electronics, electrical, mechanical, all these things, first and foremost thing that I always ask or always say, what do we mean by this term electronics, electrical in a broader sense? This is my very first question that I always ask. Or how do we differentiate between an electronic device and an electrical device? What we find, suppose if we have a fan, say electric fan, the ceiling fan, and if you have your say smartphone, obviously we will say that one is an electrical device and the other is an electronic device. In some cases, people say, no, sir, nowadays we are also talking about the electronic fan as not to be only the electrical device but also electronic, because we have the sensors. We are controlling the speed with that sensors. Some temperature control sensors are also present. So that is making this fan not to be referred only as an electrical device but also as an electronic device. So what is the basic point of difference? So we find that that is a particular point of operation within that fan that we are referring to as an electronic by the electronic component. But fan as a whole, if we see, it is basically the electrical device. Now, how do we differentiate between these two, electrical and electronics? So we observe that when we have studied for the first time physics, maybe in class 6 or 7, or maybe before that, when you have first come across the term electron and you have come across a term which was electric. So this is when you have started identifying or understanding the concept of charge. So when we say electric charge, over there we have studied that whenever there is a particular charge present, there is a concept of a field, electrical field, a field present, and we can have some kind of measurement of the flow of the charge. And when we say that there is a particular element present, so that means there is the case of the electron, proton, neutron present, and that we have studied at the very fundamental point of our, whether you consider physics or whether you consider chemistry. So in this particular topic of electron, proton, neutron, we have studied in our physics course, our chemistry course, everywhere. So what we observe, that when we have this electron present and we are trying to know the dynamics of it, that means the flow of the electrons, we are referring to that branch as electronics. So that means, imagine that if I am holding this phone in front of you, then you will say, yes sir, this is a smartphone that you are having, or you are holding a phone. But if I just have a structure like this, you are not able to identify whether this is an electronic device or not. Only when we are trying to tap on the screen, we are opening some application and you find that it is in an operating condition, then only you can say that this is an electronic device. It can just be a black box, just a black box without any function. So by looking at it, you cannot say anything. You can only say when you find some kind of application running. That means you have some, how do we say, or how do we define this application running? Some flow of electrons happening within the system which shows some response by some kind of variation that we can visibly note. Then from the electrical point of view, what we find? It is the flow of the electric charge. But how it happens? When we have the variation of potential. So this AL term that we come across, we can safely say that it is basically a part of the term that we are referring as the potential. Whenever there is a variation of potential, then only we will find that the charge is flowing from one side to the other, and then we can say that that is going to help in the device to operate. So that means electronics deals with the dynamics of the electrons, and electrical, so that means within that electrical device, so whenever we are connecting the laptop, whenever we find anything, so there is a flow of the charge, and what happens, that adapter controls that amount of voltage that is required for this laptop to run. So it will be scaling down the particular voltage level up to that level which is acceptable. The same thing happens for our smartphone also. So we don't require that high voltage. So it is operating maybe in a low voltage condition, but how that will be operated, that is regulated within the system by the flow of the electrons. And also some of the circuit components that we have within the system, they require maybe voltage of some nanovolt level, some require of some millivolt level. So everything is regulated by the flow of the electrons within the system. So this is the very primary aspect that we find within electronics and electrical. So this is one very major aspect, one major aspect that I always try to discuss when we are trying to take up a subject like this, like electronic measurement. Next point, those of you have studied digital electronics, you know very well. Otherwise, if you have not studied digital, or if we just try to portray in this way that how the numbers are generated. Suppose when we say that, say for example, say how we get the digital counterpart, digital representation for say 5, decimal number 5. So many of you know how to calculate. But again, if I say how these numbers are formed, for the very first point, what we find that when we talk about these numbers from the decimal point of view, then we know that the numbers are represented as say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We all know that 0 was not there at the beginning, it was discovered in India, but still I am not going up to that level of discussion where 0 is discovered, 0 is formed, what is the essence of it. But one thing we accept, that the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, this is an axiom. Like if you ask me why white is white, what is the color of this page that I am writing? White. Why this is called white? What is the color of the pen that I am using to write? Black. Why this is black? So this is an axiom that we accept. So at this point we accept this, that 0 to 9, this is an axiom, this is 3 looks like these 3. দেখবে ছোটবেলায় অনেক সময় হতো, I have seen many of my like cousin or my other relatives also, when their child are growing up, definitely I don't remember my past in that way, that I am writing 3 in this way. So they cannot recall. So what human brain is registering, that 3 looks like this, it is just an image. So this is how we are trying to recall. So if someone taught that 3 looks like this, then we probably would have written 3 in this way. But that is not the case. But after 9, what digit will come?
10.
10. But why it is 10?
স্যার বেসিক্যালি নাম্বার সিস্টেমে তো ম্যাক্সিমাম রেস্ট, ইউনিক ডিজাইন এবং মিনিমাম চেঞ্জের উপর করা হয়।
বেশ, ঠিক।
এটা তো আপনি বলেছিলেন আমাদের ক্লাসে।
একদম আমি বলেছি, আমি জানি, আমি যেন দেখলাম যে তুমি বলছো কিনা এটা। রাইট, সেটা আমি সেই তখন করিয়েছিলাম। দেখো 9 এর পরে যখন আমরা যে কোনো, এইটাই হচ্ছে এবার ফান্ডামেন্টাল, দ্যাট হোয়াট উই কাম ইন এনি ডিজাইন পার্সপেক্টিভ, that when we have any particular design which we will try to measure then its efficiency, then what we observe, how much rest we have given to that circuit. That is one very important aspect. Then whenever we are trying to give any rest to that, and we are trying to design another variation from that particular level, we want minimum change. So you will observe that for any human psychology also, if we say that, acha, you are having GATE exam, so today let us take 3 classes. এই লাস্ট 2-3 সপ্তাহ ক্লাসটা হলো না, let me take 3 classes together, then automatically you will say, না স্যার আজকে নয়, একে তো আজকে 14 তারিখ, স্টেট গভর্নমেন্ট ভালো ভালো একটা ছুটিও দিয়ে দিয়েছে, আজকে স্যার একেবারেই হবে না। তারপরে আমি যদি বলি তাহলে কালকে, না না কালকে তো স্যার ইউনিভার্সিটি আছে, আমি বললাম সন্ধ্যেবেলা, তাহলে ইউ উইল ফাইন্ড দ্যাট, আচ্ছা ইউনিভার্সিটি করে ল্যাব করে এখন পরীক্ষাও শুরু হবে, মানে এই সেমিস্টারও চলছে, মাঝখানে ক্লাস টাস চলছে। So you will find that you are trying to get a timing which suits you, in a sense that you are getting into a comfortable situation to handle a particular class. You will observe that this has become a general practice that I am observing over the time, that most of the cases your lab sessions are in the afternoon. Why? Because the theoretical classes you will handle at the beginning. So amount of load that you take, that is at the beginning when your mind is fresh, and then in the second half you will have the lab sessions. Unfortunately, in most cases what we are observing now, that you are directly coming for the lab, you are taking too much of rest. Maybe you are in the campus, you are enjoying with your friends, but you are not coming to the class. তাই তো এরকম ঘটনা ঘটছে, I think তোমরা এরকম বদমাইশি করেই চলেছো। So this is a situation that we come across, that maximum rest phase, whether you do it consciously or just by practice, This is the habit that is happening. আচ্ছা চল অনেক গল্প টল্প হলো, এবারে অন্তত ল্যাবটা গিয়ে করে আসি। Whenever you are doing the lab also, still you see, when you are writing the lab reports, you are waiting for someone who is very efficient in your writing reports. He is expert writer, so he is going to complete, he or she is going to complete the report, then you are trying to copy. Then I say, always say to all my students, if you are really planning to copy, make sure that the components that you are using during the lab, they may have a different variation while you are recording the data. So if you are mentioning your particular component, if you copy the graph from your friend, that may not satisfy with the data that you are putting. So either you have to copy the entirety with the entire report, so that you are copying the every single data with reference to the component that you are using, or you have to be very careful that you are performing your own experiment and you are writing the own data. So that means this is something that we have. So your target is minimum change at certain point, maximum rest, minimum change. যেটুকু চেঞ্জ করলে আমার হয়ে যায় আমি সেইটুকুই চেঞ্জ করছি। But this is the general tendency. But when we find that we are trying to perform any kind of design, this is a demand of the hardware also. So like human system, if we consider as a hardware, the what we consider as our conscience which is developing, a hardware also demands a similar thing. And the third point that Amit has also mentioned, that whenever you are trying to go for any particular design, what we are looking for, it is basically unique. So what we find after 9, we observe that which one has been taking the maximum rest, and we observe that 0 is taking maximum rest. So we try to fill up the next point by 0, but what we observe, 0 has already been taken up, so it is no longer unique. So what is the next number who is taking maximum rest? That maximum rest after 0 is being taken by 1. So we try to take the next component, the next variable which is represented by 1, and we try to fill up this space by this 0. Now mind the case that this is a particular hardware 1, this is the next bit which is represented by hardware 2. তাহলে আমরা যখন ছোটবেলায় পড়েছি units place, tens place, hundreds place, like that, this is from the pen and paper system that we are working with. But when we are implementing that in the hardware level, then what we find, it is the next bit representation. Say for example, if you consider the 7 segment display, then what we find, this is one 7 segment display followed by the other 7 segment display. So if this particular is reaching the maximum, then it is going to set the next bit. You take up any of the clocks like the Shialda station or the Howrah station, wherever you are coming through, you will find that what happens, you have representation as 00:00:00 like that. So somewhere down the line you have the minute, you have the hour, only these two are displayed. But if you have the seconds also, then what we find, after 59 this is going to be reset back to 0. So 0 to 59, this continuously is going through, and this is also going through from 0 to 59, and this is going up to say 23, 0 to 23. Why? Because if you are going from 0 to 12, if there is any problem anywhere at certain point, people might get confused at timing, say for 7 p.m. or 8 p.m. that what is the, suppose 9 p.m. it is not displaying properly, so people might get confused, those who are not understanding the timing carefully. So you will observe that always it is the 23-hour slot which is maintained to keep track of every single detail. And very important point is, if you observe from the train timing point of view, none of the trains at any point of time from any station starts at 12 o'clock. The reason being, if it is like 00:00:00 like that, then people will get confused about the day of its departure. So even if a train starts its schedule like maybe it is coming on way, it is going to be reaching at a station at say 12 o'clock, they will either make an arrangement to have a signal so that the train gets a delay by 1 minute or so, or the train reaches the station at 23:58. So this is a very very important perspective. Those of your relatives who are in Indian Railways, if you ask them, you will get a very good confirmation of this fact, that whenever the terminal destinations are chosen, either or terminal stations from where the trains are going to start, even they are never going to be 00 hours timing. It is always 1 minute before or after, like that. So this is a particular check to avoid any confusion, so that this uniqueness is always maintained. Now after this 10, what will happen? So after this 0 again, 1 is the next point. So if this is the next hardware, so we are keeping this 1 engaged, we are keeping this 0 fixed. So we are not changing. See, this is going for the maximum rest. So you have specified a value and you are keeping it as it is till it requires a change. So once it is coming to this 1 up to say 19, it will go on. Then from 9 it goes back to 0. If you try to go with 1 again, already 10 has been taken up. So it will check the next bit which is taken maximum rest. So it will go down to 20. Like that, you will go up to 90. Similarly up to 99. And after 99, what happens? 9 goes back to 0. This 9 cannot continue as 9 because that will be a repetition. So it goes back to 0. And you observe that 00 has already been taken up. So now it demands the next hardware to be considered, which is going to take the carry of the previous stages to the next level. So what we find, that whenever we are trying to take the different bits, in mostly the electronic students, they have studied that when we are trying to refer to a circuit level as an adder, you have a sum and then there is a provision for the carry which is going to be carried to the next stage. So if we are considering a situation as A0 B0 producing a sum C0 and a carry C out, then it is going to move into the next bit, into the next hardware, which is like taking some A1 B1 producing a sum S1. With the help of this carry C0, it is producing another C1 as the carry. So that will followed up by another adder circuit and like that. So this way we can scale up continuously to generate or to have new hardware giving us more robust designs. So this was the very basic aspect, and why we have studied decimal, because of the case of we are having 10 fingers in our hands. So from the fundamental point of our childhood, when we have studied the decimal system, we observe that it is our normal sense that with 10 fingers we can have this counting. So 0 to 9 is something we are comfortable with. But it became very difficult as a situation when we are trying to define these numbers to a computer. So what it was done, that 0 has been taken as 0, where this 0 refers to very important 3 stages. 1 0 as a value we can take. By this 0 we can refer to a state. By 0 we can refer to a logic. So when it is with value, it is 0. When it is with this state, we are considering off. Whenever we are considering a logic, we are taking it as low. And 1 was taken as 1 with the sense value can be 1, the state can be on, and the logic state, if we consider, that is noted as high. Rest of the things, the similar logic follows. After 0 1, who is taking maximum rest? 0. But this is no longer unique. So after 0, who is taking maximum rest? 1. So you fill up the other spaces by 0. For 3, what happens? After 0 it is 1. So if you continue with 1, still it is unique. So after this 3, 4, if you try to consider, after 1 it is 0. You cannot continue with 1. That will be a repetition. So it goes back to 0. 0 0 is already taken up. So you have to move to the next hardware level. This is the next bit level as 1 0 0. So what we have observed, that in school level also, or even in the engineering level also, when you have studied these conversions, the idea was, if you have any number, say for example 5, then if you're trying to go from decimal to your binary number system, the idea was you divide by 2 and you collect the remainders in the reverse order. So what we find, that 5, if we divide by 2, 2 2s are 4 with a remainder 1, 2 1s are 2 with a remainder 0, 2 does not go within 0, so the remainder is 1. So this 5 in decimal, if we try to represent in binary, that becomes as 101. See, we cannot say 101, we don't know how to pronounce it. Just like the case of, if you're writing rupees 59 rupees 25 paisa, you can say 25. But when you're writing any kind of like number as say 59.25, you cannot say 25. So we know that after decimal we don't know how to represent, but we can say 59 rupees 25 paisa, because this is represented by a different denomination altogether. But when it is like a say 59.25 grams, we cannot say 59.25 grams. So this was the very basic aspect, that we don't know how to pronounce it. What is beyond this decimal point? The same thing, we don't know how to pronounce this binary number also. So we say 101. So we are not going to say 101. So this is how we find that the binary number system has been generated, and what is the utility of it? Now with the situation that we are going through, we observe that whether you consider a 2-bit system, whether you consider a 3-bit system, 4-bit system, if we can have a 2-bit system clearly defined, we can extrapolate it to generate a 3-bit, 4-bit, 5-bit system, whatever you want. And when we consider any of the engineering disciplines, now we find that data storage, digitization, then assessment of the speed, everything has become a very, very critical aspect. So people are trying to focus with the electronic switches, people are trying to focus with the measurement parameters which are governed by the electrical and the electronic measurement equipments. And so in the entire process, we are trying to look for the measuring devices, measuring instruments which are consuming less power also. So when we are trying to encompass so many features into one particular state, we find we have to modify our state of art altogether. So though we will find that when we are studying some robust electrical systems, we need to know or we need to study, but in the industrial point of view, when you come, you will find the front end systems are mostly in the digital segment. That means either you have a switch on, switch off knob, either you have some kind of threshold values defined by some 0, 1 levels. So some kind of levels, some kind of parameters, everything are defined so that the complexities can be reduced at each level. So when we take any 2-bit system, then what we find, that 2-bit system means we can have 0, 1, 2, 3, and its representation in the binary is given as 0, 0. Just now I have written 0, 0, 0, 1, 1, 0, 1, 1.
Sir.
হ্যাঁ বলো
Sir, one of my friends tried to join, but
নিয়েছি ঠিক। অরিন্দম হালদার, এই তো আমি স্ক্রিনটায় ছিলাম আর দেখতে পাচ্ছি না।
আচ্ছা।
হ্যাঁ, এইটা একটা জিনিস ইম্পর্টেন্ট বলে রাখি, সেটা হচ্ছে যে কোনো সময় যদি দেখো যে মানে right now 36 of you are present probably, or 35, if you find you are not able to join because of the point that you are joining late, I am sharing the screen so I cannot see. Please try to communicate to your friends, or maybe if you are even dropping a WhatsApp also, I won't be able to check that. Just inform your friend that you are not able to join. ঠিক আছে, এরকম হলে জানিয়ে দেবে আমাকে। হ্যাঁ, ও পরে জয়েন করেছে তো, জন্য মিস করে যাচ্ছে। এনিওয়ে, আর কেউ মিস করেছিল নাকি? আমি অবশ্য দেখতেও পাইনি। এই ছিল তো অরিন্দম হালদার।
হ্যাঁ স্যার।
আচ্ছা, তাহলে দেখো, তাহলে what we find that when we are trying to consider this, that 0 1 2 3 we are trying to move to this situation as say 0 0 0 1 1 0 1 1. Now this particular aspect, electronics, electrical, and maybe computer science students have also studied. I'm not sure about all other disciplines whether you have gone through these half adder, full adder designs. But one thing is very interesting, that when we are trying to consider any system, we always say that this is enough for any system to be defined. What does it mean? Suppose you consider a situation that you are trying to add. ছোটবেলায় যখন সেই C program এই সমস্ত করা হতো, then what was the idea? That if you are taking two variables A and B, in some cases at the very beginning we used to take another variable C, and then we used to make it like this, that C is going to be A plus B, right? Then at some point of time we learned that acha, if this is like my one hand, say this is my left hand and this is my right hand, then I can make the addition like this, that let whatever I have in my left hand I am keeping it, or whatever I have in my right hand I am keeping it in my left hand, and I am asking again for the next data. So in that mode what we were writing, B equal to, in programming mode we were writing B equals to A plus B. If you are thinking of normal mathematical calculation, someone will say are B to tale kete gelo, but we know that when we have written the program several times we have written that, and what it was referring to, that this B is B new and this B is B old. So at the same time what we have done is we have ignored another variable C, so that we are not occupying extra space in the memory. So with the same variable being referred like a temp, we are trying to make the calculation happen at that point only. So that B equals to A plus B, the calculation gives us this B as the new B which is given as an addition. So what we find, that whenever we are trying to define this kind of hardware A, B, so we are trying to perform some addition and it is going to produce that sum, then we may have a carry, and maybe there was no carry, this is the zeroth state or zeroth stage, or the maybe say let me refer this as the first stage, you don't have any carry. So when we have the next level, see again it is still A1 B1, that means we are trying to refer to the two variable situation. The electronics, electrical students, those who are present, or maybe other disciplines also, since I am not sure whether you have studied this, probably will say that sir, when we have studied half adder circuits we have done with this A, B and produced the output as some sum and carry, sum and carry. And then when we have produced, or when we have written this full adder circuit, then we have considered these as the variables as A, B, C, and then we have again written these as sum and carry out, and over there we have tried to represent this as a 3-bit circuit where we have written it as 0 0 0 0 0 1 0 1 0 like that. Is it so? Electrical, electronics, or any other discipline who have studied digital, have you represented the full adder circuit like this? কিছু ছোট ছোট ভ্যারিয়েশন ছিল, anyone would like to identify or highlight here? কই অমিত আর বাকিরা?
হ্যাঁ স্যার বলুন, কোশ্চেন আসলে মিস করে গেছি, একবার বলুন।
হ্যাঁ বলছি এই যে ফুল অ্যাডার মিস করে গেছে মানে চলে গেছে খেতে,
না
অনলাইন মানেই হচ্ছে পালিয়ে যাবে।
আরে না না স্যার আছে, বলুন বলুন বলুন।
তো দেখো যেটা তখন হচ্ছে যে whenever we have studied this particular full adder circuits like that, so in many cases we were trying to represent like 0 0 0 0 0 1 0 1 0 like that, and in some cases those of you have studied those generate, propagate, kill, I'm not going into detail about these aspects, those of you studied will recall that. But the point of concern is, what I want to say, that if you open any book, what I have seen for any digital electronics book, they always write it in this way: 000010010, 001010011, 1001001, 110 111, like that they are representing. But my point of view is, we should not think it in this mode, but how we should think. If you observe that the first value for the 2-bit system was 00, when it moves to the 3-bit system, we are considering that for the 00 we can have a carry or we may not have a carry. So it basically takes care of the two situations, like 000 and the other situation as 001. Again,
এক্সকিউজ মি স্যার
হ্যাঁ বলো।
স্যার বলছি এই ক্যারিটা একটু আরেকবার বোঝাবেন?
হ্যাঁ হ্যাঁ বলছি। দেখো, what we find that when we have any kind of adder circuit, then what is referred to, that we have 2 bits referring, we generally refer this as AI BI. So whenever we are performing any addition, so if you want to add, obviously what you require the operand and the operator. So over there, when you're adding, you must have at least 2 variables. Otherwise it is exactly whatever is coming is going straight, just like the case of a buffer. So when we have over here adder, so it is going to produce some kind of a sum, there will be some kind of a result. But when we are producing this sum, there is a possibility that this sum is not able to represent or to what should I say, to produce an output which is restricted to a single variable only. There is a chance of some overflow, just like the case of when we represent 9 plus 1 in our normal decimal way. When we say 10, it is basically 9 plus 1 0. So if you see, what I was trying to focus here, that after 9 it is going down to 0, but this 0 is not a unique number. So what we find, what is the next bit which is taking maximum rest, so that it can give me a unique number, that is 1. So 9 plus 1, whenever we are trying to represent, it basically represents a state as 0 with a carry 1. So this carry is going to be taken up or going to be displayed by the next bit or next hardware which is available in the situation. So what we find, what I was trying to refer here also for the 7 segment display, suppose you have 23 hours 59 minutes 59 seconds. After that, if we pass 1 second, then this is going to go back to 00, because of the case that there is no provision of it going to 60. So this 00, what happens? So 9 plus 1 0, the carry is coming over here. 5 plus 1, see, in this particular case its restriction is up to 5, it cannot go up to 6. So 5 plus 1 is 0, again there is a carry. 9 plus 1 0, there is a carry. 5 plus 1 0, there is a carry. 3 plus 1 0, there is a carry. 2 plus 1 0, there is a carry. It cannot display. So that means if there was a chance of a display, then beyond this point I must have, if this is like hour, minutes, seconds, then beyond this point I must have something like day, isn't it? So it should be like day 1, day 2, day 3, like that. And if it goes up to, say, if I consider it in this way, that I will consider up to 365 days, like that, then there should be another point as years. So in this way, the count should go on. So because of the fact that we don't require this, what happens? Once it is up to that point, it is resetting back to the 0000 mode. So this is a very, very interesting situation that we define, that this is a periodic function. And what is its periodicity? Periodicity is off by 24 hours. তাহলে দেখো, যখন আমরা রিপ্রেজেন্ট করছি এনি ক্যারি, the idea is it keeps on moving, the circuit keeps on moving the stages one after the other. So it is progressing. Just for the case of, let me give you a very, very simple example. Say you have gone to any hill station to observe the sunrise. By chance, maybe because of cloudy weather, or maybe because you fell asleep, you missed the sunrise. Then you are reaching at say 7 a.m., 7 o'clock, and other people you find are coming down the hill, and people are saying, "Are you are coming now? Now the already the sunrise, the beautiful scenic beauty is gone. You cannot view that anymore." So you are waiting and you are thinking, why can't I get that opportunity to see it once again? So definitely then someone will say, yes, you can get that opportunity, but there is a periodicity of 24 hours. You have to wait for the next morning. So that means we have a situation that either we have a signal where the periodicity is of some 1 second, we can have a signal where the periodicity is of 1 minute, 1 hour, 1 day, 1 year, anything like that. Say for example, celebration of a birthday. You cannot have your birthday celebrated every day. Some cases people have like extended birthday celebration. আজকে বাড়িতে হয়েছে, কালকে ওখানে হচ্ছে বন্ধুরা বলেছে পার্টি দিতে, but that is a different aspect. Your birthday, that is not going to come every day. You are celebrating, that's a different story. So that means it is again a periodic event which is happening once every year on a particular day. So that means we find there is always a periodicity factor involved in any kind of design that we are looking for. And in this case also, when we are looking for a particular adder, with this sum a carry is produced which is a CI. Now if this is the first stage or the 0th stage, then we will be referring this as A0, B0, S0 and C0. So if this is the 0th stage, the next stage of the hardware, if we connect, this is going to be referred as A1, B1, the sum as S1, and so with this carry as the input, you are going to produce another carry which is as the output. So now you observe, instead of 2 variables, you have basically 3 variables. Are you observing this? At the very first stage, this was 2 variables. So this is the situation that we refer as a situation of half adder. But when we come across a situation where we can take care of 3 variables, we are referring to the full adder. And in many of the discussions related to the electronic circuits, there are a lot of such designs, lot of complex hardwares which are producing, which are trying to take care of these full adder circuits in different mode. মানে আরো কমপ্লেক্সিটি, যত কমপ্লেক্সিটি বাড়িয়েছে, যত তার আরো কিছু অ্যাডভান্টেজ কে জেনারেট করানোর চেষ্টা আছে, যত তার মনে হচ্ছে পাওয়ার কনজাম্পশন কে কমানো যাবে, lot of modifications have been done with reference to the full adder circuits. We are not going into those aspects. That is not our point of discussion. But my point of discussion is that when we have taken this half adder circuit, we note that A and B can take the variables as 00, 01, 10, 11. That's it. For 2 variable, you don't have any other variation. Why? Because if you refer to the situation as 4, it gives us the binary equivalent as 1, 0, 0. That means A and B are going to go into the 0 state. তার মানে 3 এর পর আর কোনো রিপ্রেজেন্টেশন আমরা হাফ অ্যাডার দিয়ে করতে পারছি না। So when we take care of the next bit as the 3 variable, then what we observe? We observe that in this circuit I may have a carry coming, maybe a carry 0. So some people will say sir carry 0 মানে কিছুই carry নেই, okay I accept it, but you may have a carry 1 also coming, so that needs to be taken care of. So we said in that perspective either I can have a 0 carry or I can have a 1 carry for every single stage of A and B that we know. তাহলে A আর B আমরা জেনে গেছি যে 0 0 0 1 1 0 1 1 হতে পারে, তাহলে ঠিক প্রত্যেকটাই 0 0 0 1 1 0 1 1, এই প্রত্যেকটার জন্য I can have a situation where we are going to get either a carry is present or a carry is absent, either a carry is absent or a carry is present, like that. তার মানে আমরা বলতেই পারি it will come across a situation like this. তাহলে if you observe যখন 3 ভেরিয়েবল রিপ্রেজেন্টেশন হচ্ছে it is basically 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 1 1 1 1 0 1 1 1. তাহলে আমরা যখন 3 ভেরিয়েবল রিপ্রেজেন্টেশন দেখছি, when we are trying to represent a 3 variable system in a digital circuit, we find the representation is like this. And technically when we are trying to refer to the situation over here in binary system, then what we in decimal system the states are 0 1 2 3 4 5 6 7. আমি এগুলো হচ্ছে কাউন্ট হিসেবে লিখলাম 1 to 8, কিন্তু যদি স্টেট দেখি তাহলে 7 এর বাইনারি ইকুইভ্যালেন্ট হচ্ছে 1 1 1 রিপ্রেজেন্টেড বাই দ্য গ্রিন কালার, 6 এর রিপ্রেজেন্টেশন হচ্ছে 1 1 0 রিপ্রেজেন্টেড বাই দ্য ব্লু কালার। তাহলে এই যে 0 to 7 that we have for the decimal, the binary equivalent can also be assumed in this way, where I am not going to say it is just A B C 3 variables, but I will say variable আমার দুটোই A আর B, আর থার্ড যে ভেরিয়েবলটাকে আমি ভাবছি that I am considering as a variable is somewhat a grade 2 variable, বা একটা বলতে পারা যায় intermediate variable, which is going to come either with a 0 or with a 1. And what is the situation now? The most important term that we come, that it is a state which is dependent on the previous hardware value or the previous history. So the previous history, okay, it depends upon the history of the variable. তাহলে তুমি একটা জিনিস লক্ষ্য করে দেখো, if you consider, দেখো আজকে যেহেতু এতগুলো ইঞ্জিনিয়ারিং ডিসিপ্লিন তোমরা একসঙ্গে পড়ছো, if I try to take in this way, say for any biological system, if you go to a doctor, the doctor will probably say that do you have any kind of history of some problem, ধরো তোমার বুকে ব্যথা করছে, কিছু একটা হয়েছে somewhere, whatever you are suffering from, maybe you suffered from mostly many of us in the second wave have suffered from COVID. তো এখন যদি ডাক্তারের কাছে গিয়ে বলো কিছু একটা your problem, doctor is going to probably ask did you suffer from COVID, did you have any other problem? So many things doctor will ask, so that means they are asking, they are trying to check for your previous history. So depending on whether you have any other suffering, whether you had any other problem, they are going to refer based on some history, or what they do, they will ask for some diagnosis. হয়তো বললে একটা ঠিক আছে পায়ে চোট লেগেছে, কিছু একটা হচ্ছে প্রচন্ড যন্ত্রণা, so they will say that you get an x-ray. You have some kind of stomach pain, they will say you go for an ultrasonography. So you will find that everywhere whatever we consider, there is a chance of, or there is a aspect of measurement, and that measurement takes care of different aspects. And how that measurement is done, that measurement is done with reference to some particular parameters which will be calculated by help of that particular instrument. যদি ধরো তোমার দেখা যায় যে suppose say you are having fever for quite some time, doctor is asking for a blood test, that means in the blood component there are some parameters. Doctor is going to estimate that, and from that he can come to a conclusion based on the recorded history of different patients. তাহলে এরকম নয় যে ধরো কেউ যখন দেখছে কারোর ধরো হিমোগ্লোবিন কম্পোনেন্ট কমে গেছে, তখন ডাক্তার বলছে আচ্ছা তার মানে ইউ আর সাফারিং ফ্রম সাম অ্যানিমিক ট্রেন্ড। ইট মে সো হ্যাপেন দ্যাট ইউ হ্যাভ সাম অ্যানিমিক ট্রেন্ড, or it may so happen you have some kind of strong infection which is suppressing or which is affecting your hemoglobin RBC count. তাহলে এই যে জায়গাগুলো রয়েছে, তাহলে ডিফারেন্ট অ্যাসপেক্টস পিপল আর ট্রাইং টু লুক ফর, অ্যান্ড অ্যাকর্ডিংলি সাম, তাহলে এই মেজারমেন্ট গুলো থেকে হোয়াট উই ক্যান ফাইন্ড, উই ক্যান কাম আপ উইথ সাম কনক্লুশন বেসড অন আগে কি ছিল, আগে আর সামনে কি হতে যাচ্ছে। Ankit Prasad, you are writing what is half and full adder circuits. Are you getting this point?
Yes, sir. I wrote it a while back. I understood
Yes,
it.
now, just now I checked it because I came back to the main screen. Okay, so this is what we are trying to refer. So again, just to be precisely defining that when we say half adder, technically as a term we refer as a half adder. Half adder is nothing but a situation where we don't have a provision for previous stages input to be taken. Okay, half adder. And what is full adder? You have the previous stages output to be considered. So if you think of a situation like a traffic signal. So most of the students from electronics, again they have studied in this mode only, that when we have a traffic signal, what we find, suppose you are waiting at the Jadavpur police station signal. So if you find that the your north-south domain, the north-south roads are open, that means the east-west are going to get a red signal, you cannot move. So after maybe a 60 seconds interval or so, the signal is going to change. That means those who are getting the green signal is now going to get the red and the other way around. So what does it indicate? That means the other way is dependent on the previous stage, and since they are getting 60 seconds green signal, for the next 60 seconds the other east-west crossing road is going to get the green signal. But you will observe in between it may so happen that any VIP person is suddenly coming. Suddenly you will find you're supposed to get the signal at 60 seconds point, but the signal did not turn up in your favor. 0-0 হয়ে গেছে। দেখবে অনেক সময় এই ঘটনা হয় যে 0-0 হয়ে যাওয়ার পরেও সিগন্যাল খুলছে না, it's not showing up, it's still showing red and it's still showing green to the other section. So what happens? This is now a situation that we refer as a forced reset. তার মানে সেইখানে ট্রাফিক ফোর্সিবলি বসে রয়েছেন, and he is keeping the green signal on for the other side where he got information that any VIP person maybe is coming, so he need to keep the road clear so that he may pass. তাহলে সেইখানে গিয়ে we are trying to generate some kind of interrupt into that signal, so that I have to think that as an exclusion of the normal measuring system or the normal circuit design or the normal procedure that we have come across. ঠিক যেরকম ধরো আজকে যে ক্লাসটা হচ্ছে, তোমাদের নর্মাল যদি হতো I would have never taken a class at this time because I will be in the university, you will be in your respective departments, so you cannot attend the class. But today, since there is an official holiday, so technically you will say that official holidays are apni class nichen. Yes, that's why I mentioned je shobai barite ache, this is an online class, so this is like an exception we are trying to do with reference to the point that all of you most likely are at home. কিন্তু তারপরে যেরকম কালকে গ্রুপেতেই লিখছিল কেউ একজন যে ইন্টারভিউ রয়েছে, তাহলে দেখো সেইখানেও কিন্তু there is again another exception coming up that someone is having other engagement also with this particular day. So if we have such kind of situation arising, then we might require some forceful reset so that the circuit can be tuned based on specific requirements. So that means we find whenever we design any particular circuit, there must be some kind of a master control which can have a final say if the circuit somehow goes out of control or goes out of bounds. প্রত্যেকটা জায়গাতেই দেখবে প্রত্যেকটা সিচুয়েশনে you have a particular reset mode in any kind of measuring system. যে কোনো কিছু তোমরা প্রত্যেকেই ধরো, maybe some of you play say synthesizer, maybe some of you play some other instruments, maybe some of you are with some particular doing some any other work with any other thing. If you cannot manage any particular thing, what you do, you probably go on for a hard reset, probably you go on for a switch off situation. আমাদের যে কোনো ডিভাইসের জন্য দেখি, তার মানে when we are trying to do with that a restart of the system, resetting the system, what it does, it basically takes you back to the 0 state so that you can start fresh again. Maybe in between when these bits are produced, when the intermediate states are produced, they are not able to sync. They are not able to sync with the continuous function that we are going through. So this is a very, very important stage or state that we look for. You will observe that why I am talking about the traffic signal, because this is a very common point that we all observe in most of the cases. যখন ট্রাফিক রাত্রিবেলাতে চলে যাচ্ছে, you will find they open in many of the roads, not for the main crossings, they will put it in the mode where every side you are getting a yellow light, the amber color blinking. তার মানে পুরোটাকেই অফ করে দিয়েছে। এবারে হচ্ছে now it is a factor which is dependent on the common people that you observe and you cross the road. In some cases you will find that some of the roads are one way from 7 a.m. to 1 p.m. and the other way opens from 1 p.m. to 10 p.m. After 10 p.m. it is both way, but the signal is not operating for both way, it is operating for one way only. So at that time people have to be careful and they have to make their movement by checking every side whether any car is coming or not. That means whenever we are trying to move through any particular system, if I consider the entire traffic monitoring system as a huge, complex and complicated system, we find these vehicles that are moving are some variables who are given with some kind of intelligence to check whether I should go or not. কিন্তু যখন তোমার কাছে সিগন্যাল খোলা রয়েছে, তুমি একটা জিনিস দেখবে, কোনো সময় যদি এরকম হয় ট্রাফিক সিগন্যাল ফেল করেছে, মানে দুদিকেই গ্রিন হয়ে গেছে, দুদিকে রেড, নো প্রবলেম, কিন্তু দুদিকেই যদি গ্রিন সিগন্যাল হয়ে গেছে, some people are deliberately, that I have observed, this happened very, very limited number of cases, but I have observed this, that people are deliberately, আমিও তো গ্রিন সিগন্যাল পেয়ে গেছি, চলো চালাই, কিন্তু people observing that maybe people will say আমি তো দেখতে পাচ্ছি না ওদিকে গ্রিন সিগন্যাল পেয়েছে, but some people who have observed that there might be a problem, they will immediately stop. So this is a very, very interesting point that we observe, that nowadays when we are talking about any measurement system, when people are saying that let us incorporate some intelligence into a particular circuit, intelligence into a particular system, so that it can take care of any kind of disruption, that we are referring to a measurement system equipped with some artificial intelligence or measurement system with some kind of data analysis and modeling systems incorporated. So nowadays everything is getting updated. You will find that many of the courses are also introduced into the university curriculum, where it takes care of, like for the electronics, we are offering from the electronics department one particular course, brain mapped computing. So that is something absolutely different. None of us, even in our undergraduate level or even in our postgraduate level, have studied, but this is a very, very new thing that people are working with. Why? Because every day when we are trying to design some new circuit, new concept, the idea is Can we improvise on top of that? And now with this intelligence factor, everyone is speaking about intelligence everywhere, wherever we look for. And nowadays you are seeing that this chat GPT, probably all are aware of these things. People are saying that if these things are dominating, they are going to kill half of the jobs of different people. So many people are assuming that if we incorporate so much of intelligence, whether that will be a good for the design or whether that can create some problem in our measuring system also. তাহলে আলটিমেটলি গিয়ে আমরা যাই দেখছি, আমি ওই জন্যই প্রথমে জিজ্ঞেস করলাম, আই ওয়াজ আস্কিং হোয়াট ইজ ইউর আউটলুক অ্যাবাউট দিস পার্টিকুলার কোর্স। You will find that when we are talking about the ammeters, when we are talking about the voltmeters, whether we are talking about the energy meters, whatever we are trying to consider, they are trying to take care of several level of intelligence into the next level. If you consider the electric supply meters, if you know the billing strategy, if you are consuming this many number of units, you are falling into a particular slab. Just like the case of income tax file return, people are, whenever this budget is coming, people are so excited. People are, maybe you are not excited at this point, maybe in another next year or so you will be very excited with budget. And so many people who are earning to that level, they will be excited, acha budget e ki holo, koto taka tax hobe, kon slab e hobe. The same thing comes with the aspect that when we are trying to design any circuit, what is the level, how much is the threshold, can we increase that threshold, or what is the restriction? So this way, if we try to formulate, we come across various classifications. Say for example, let me just give a very very simple example, you will understand that. Suppose we have an amplifier কি করে, amplify করে, as simple as that. So suppose you are using a speaker from Frontec, a speaker from Bose, and maybe from other XYZ, many other brands. You will find that you are getting probably a speaker at a price of some 500 rupees, some speaker at some 5,000 rupees, some speaker maybe at some 50,000 rupees, and so on. I think this you have all observed. So when we say what is that factor, if you say that sir ei to gani shunchi, but you will find that there are that frequency variations, the minute changes that is been incorporated in that 50k speaker, which is probably not being able, probably not processed in a 5k speaker, or rather it is not at all processed in a 500 rupees speaker. So these kind of variations, many of you, maybe you are a vocalist, maybe you are playing some instruments. Many cases I find that many of our students are recording something, putting in the YouTube, putting in the Facebook, and they always put that particular remark, for better quality, for better clarity, please use speakers, please use headphones. I think you have also seen such kind of remark from your friends also. Why? Because the precision that someone has taken, because of the precision someone has incorporated into a system, that needs to be recorded. So when we are trying to record those variations, then we find the circuit complexity automatically increases to take care of such cases. Say for a situation, you are amplifying a simple noise. Maybe when I am taking the class, from outside lot of noise is coming, some hawkers are shouting, some bikes are honking, so many things are going. But you will observe, when you are attending the class, your conscience level is filtering out the external noises. But if you are recording a particular class, suppose you are present in the class and you are recording, if you later on listen to the record, you will find you can identify the chirping of the birds, someone dropping something, someone banging a door, many other noises which you could not listen when you are physically present in that class. And what is the reason? The reason is our normal, the human psychology, you are trying to listen to something, or maybe I'm doing this class over here, someone is doing some other job. That may so happen because I cannot control that at this point when we are taking this online class, right? So maybe at certain point of time what you will find, আমি এক্ষুনি যেমন বলে যাই, but you are listening, you are not carefully attending, but you are listening to what I am saying. If I call someone, someone will take some time and আরে আমার নাম ডাকলো মনে হচ্ছে. So you will find that any kind of circuit at certain level gets some divided attention that we have discussed in that we have seen in the different electronic circuits. Also we have multiple access based on either we have some time, based on either we have some frequency. So these kind of cases are very important when we are trying to design all these particular structures. So this amplifier that I was mentioning, suppose it is recording a particular the song of a particular person, and it is amplifying maybe in a your say fest or a freshers program, someone is singing and you have the speakers which is amplifying that. So the amplifier is amplifying that particular person's song, and you are trying to design an amplifier, maybe you are trying to see the status of a fetus of a pregnant woman. এই এক্সাম্পলটাও আমি বহু সময় দিয়েছি. And you will observe that when the doctor is trying to observe the condition of the pregnant mother and the condition of the baby growing, then the heartbeat of the mother and the fetus are going to interfere. So if I want to identify the status of the patient and the baby separately, some other low frequency amplifiers will be required which can give us that precise measurement. So when we talk about measurement, it refers to lot of variations, lot of complex designs that need to be understood. Okay, so if you go back to your class 11-12 level, and for electronics, electrical or other disciplines, maybe if you have studied that, they say the sources of energy, we have studied current source, voltage source. What are other sources of energy that you have discussed? Any other thing? How do we find a system represented? So two things that we would discuss, maybe not in today's class, but I will ask you to go through once. Suppose I have a black box. You have some input. All of you remember KCL, KVL from your school level, right? কারা কারা এখানে টু পোর্ট নেটওয়ার্ক পড়েছো? Over here, how many of you have studied this two port network?
স্যার ইলেকট্রনিক্স ইলেকট্রিক্যালটা তো পড়েছে।
আর কেউ পড়ে টু পোর্ট নেটওয়ার্ক?
স্যার ট্রান্সফরমাররাই তো টু পোর্ট নেটওয়ার্ক।
হ্যাঁ, বেশ। এইখানে এই দেখো, যখন আমরা when we are considering this two port network situation, then what we find that basically if we start with the fact of Ohm's law, then what we have seen as the statement of Ohm's law, that current that we are considering is proportional to the potential difference, right? I proportional to V mathematically. And what we have seen, we are trying to represent this I-V combination as the function of the other. So in this case, two important aspects that we find, that whenever we try to represent the current and the voltage combination, we have some parameters which are present as the input, so we have the input variables, and some of the parameters we have at the output, so we are referring that as the output variables. And we have a choice of combination of input output. So how many variables are present in total? We have V1, I1, V2, I2. And these V1, I1, V2, I2, they are going to combine in different forms to give us different ways of representation of the measuring parameters of the components of a circuit. And at the same time, with these V1 and I1, V2 and I2, we are going to find what are the various sources of energy that we have. Okay, so in that case, what we find as a very simple level, we have studied the concept of current source, voltage source at the very root level. Then what we have seen? We have seen the variations where we have কি কি পড়েছো ইলেকট্রিক্যাল আর ইলেকট্রনিক্স এর লোকজন একটু বলে ফেলো।
স্যার কারেন্ট কন্ট্রোল, ভোল্টেজ সোর্স, ভোল্টেজ কন্ট্রোল, ওইগুলো তো।
কারেন্ট, ইয়েস, কারেন্ট কন্ট্রোল, ভোল্টেজ সোর্স,
কারেন্ট কন্ট্রোল, কারেন্ট সোর্স,
বেশ,
ভোল্টেজ কন্ট্রোল, ভোল্টেজ সোর্স, এন্ড ভোল্টেজ কন্ট্রোল, কারেন্ট সোর্স।
তাই তো? ইলেকট্রনিক্স ইলেকট্রিক্যাল দুজনেই পড়েছে এটা, তাই তো?
Yes, sir.
আর বাকিরা others, have you studied all these things?
না স্যার, প্রথমবার শুনছি।
বেশ, তাহলে এই যে জায়গাটা আমি এইটুকু শুধু বলে রাখছি, আমি যেটা চেষ্টা করব যে বিফোর দ্য নেক্সট ক্লাস I will try to give you a particular document which takes care of these particular things, okay, so that before the discussion you can go through, or maybe let's see if I have the class first, then I can give you that material also. Next আমরা start করব আর next আমরা discuss করব from this particular aspect. Just a minute.
Okay, sir.
দাঁড়াও এক second. Right, so our point of view will be from this part, and once we have these the sources of energy done, then we will look for the how we are going to measure this, the voltmeter, ammeter, power meter, energy meter, and the variations under those segments. So regarding the course also, the books that you will be requiring, I will be following couple of books. So I have the e-copies with me, so what I will do is I will put it in the group as well, so that you can have the books, and if you can get it from the offline from your library, if you want that also you can have. Okay, so I will try to pass on the documents as and when whatever is required, and whatever we are going to discuss or the documents that I have, I will share it in the group itself, and in between if you have any query, please tell me. তোমাদেরকে বলেছিলাম 11:30 ছাড়বো, it's exactly 11:30, so I will leave you today at this point.
Thank you, sir.
আর next হচ্ছে যে next class we will have on Saturday, this Saturday maybe from the 10 o'clock, so 10 o'clock is okay, right? Saturday if we have?
Yes, sir.
স্যার স্যাটারডে বিকালের দিকে হলে ভালো হতো।
স্যাটারডে বিকেলে না, স্যাটারডে বিকেলের দিকে করা যাবে না, সকালেই করতে হবে, তখন দেখবে সবাই সব রকমের টাইমিং হয়ে যাচ্ছে আলাদা আলাদা। স্যাটারডে আই উইল কিপ ইট। আচ্ছা, দুটো জিনিস জিজ্ঞেস করে রাখি, একটা হচ্ছে স্যাটারডে মর্নিং থাকছে, আর আমি এটা গ্রুপেও লিখেছিলাম আগে যে in some cases we will have a class in the Friday evening also, because your schedule is three periods, so 3 periods like 3-hour class probably in one shot won't be a comfortable situation for any of us, and so in that case, because most of you, for your case it is okay, you will keep it your video and audio in the mute mode and you are happily running away. So for me it will be difficult to see that I'm covering entire portion. So in some cases we will have classes on the Friday evening also for 1 hour. Maybe that will be from say 7:30 to 8:30 or maybe from 8 to 9. I think that also will be comfortable for you all.
Yes, sir.
ঠিক আছে যদি আমি সেটা গ্রুপে দিয়ে রাখবো মানে দ্যাট উই উইল হ্যাভ আ চয়েস ইন কেস there is a situation that there is a holiday or many of us are not free on that day. If situation demands, then we can have changes in that routine, but we will keep the schedule as Saturday morning and we will have some classes on the Friday evening. Okay, that way we will have. Okay, just wait for a second, let me take your attendance. I will take the entire screenshot.
अरे इवनिंग में है सर. MS Paint. I guess MS Paint. Sir,
Yes, বলো হ্যাঁ ঠিক আছে
sir, should we refer to some resources for to get some basic knowledge over on the prerequisites like circuit theory or something? Means some book or
I will send the required documents. Okay,
okay,
whatever you require I will send those documents. You can refer to what I mentioned today, this particular portion of current control, current source, voltage control, all these current sources and voltage sources. You can search any document anywhere from NPTEL or from other university resources, anything, but at the same time I will share the documents whatever will be required for your exam purpose or for your as a prerequisite basis also.
okay, sir. Thank you, sir.
ठीक है ओके
স্যার
বলো
স্যার আপনার অ্যাটেন্ডেন্স নামে ঠিক একটু আগে আমি লিভ করেছিলাম, তো কি মানে কি করব?
দাঁড়া তাহলে তো এরকম হলে এবার ঝামেলা। আচ্ছা এক সেকেন্ড একটু
স্যার
ওয়েট কর, দাঁড়া আমি এবার এমনি নোট করেই নি, ওইভাবে করলে মনে হয় কেউ না কেউ বাদ পড়বে, পড়তেই থাকবে। এক সেকেন্ড দাঁড়া।
I'm not with anything. Okay, okay. No. 37, 38, 39. Finish the list for the
Yes. Please respond to your role. Role তো বলতে পারবো না. Respond to attendance. Let me ask you. Don't have the. Yes, I have the roll number, but that is also not. Suraj Kapat.
প্রেজেন্ট স্যার।
Present. দাঁড়াও এক second. Suraj, 1 second, please. Yes.
Yes, sir.
Yes. Okay. Present. Aniket. Ankit.
Yes, sir, present.
Dora.
Nora Mate.
Krishna. Deep.
Yes, sir, present.
Orijit. Devanko. Soham. Soham Rishi. Shyam. Bornali.
Yes, sir.
Provik Rokrit.
Present, sir.
Anubhav. Anubhav Ghosh. Masud Karim. Dipen Tudu. Suman Jolua.
Yes, sir.
Shatabdo Mondol. Sukanya Sardar.
Yes, sir.
Ramkrishna present. Devanjan present. Orithro Das. Moinuddin present.
Sir,
Devjit Dev.
present, sir. Present, sir. Hello, sir.
Ganga Murmu present. Rishabh Sur.
Present, sir.
Rishabh. Rishabh. Rishabh Sur. Rishabh is absent. Shreyan present.
Yes, sir.
Ajay Kumar. Amit Bar present. Abhishek Koyal.
Present, sir.
Sukumar Guchait present. Ashraful.
Present, sir.
Ashfaqul না ভুল বললাম
Hospital আছে কেউ?
হ্যাঁ প্রেজেন্ট ইন্দ্রনীল
Yes, sir.
আজারুল হক প্রেজেন্ট প্রেজেন্ট তো ছিল মনে হলো নেই রেফাজ শেখ প্রেজেন্ট
Present, sir.
বসিরুল্লাহ মন্ডল অরিন্দম হালদার
প্রেজেন্ট স্যার।
রজন কুমার চৌহান আশাল আনন্দ শুভজয় ঘোষ সঙ্গীতা ঘরামি
Present, sir.
অভিজিৎ
Yes, sir.
জয়দীপ সাহা
Present, sir.
বিশ্বদীপ দেব আমন কুমার শাহ
Present, sir.
Teri.
কুণাল
প্রেজেন্ট স্যার।
কৌস্তভ
Present, sir.
কৌস্তভ সায়ন অভিলাষ
Present, sir.
আলী আলী রিয়াজ ছিল না উৎপল সিং প্রতীক মাহাতো শুভম সিং সজল সরেন জিআর কিসকু সলিল কিসকু প্রীতম মন্ডল ইউসুফ করিম
Present, sir.
শুভ্রদীপ ঘোষ
Present, sir.
অনির্বাণ গোস্বামী
প্রেজেন্ট স্যার।
সূচনা মন্ডল
Present, sir.
প্রদীপ রায়
Yes, sir.
পল্লবানন্দ মন্ডল
পল্লবানন্দ
মোহাম্মদ নুরুল্লাহ
Present, sir.
সৌমদীপ দত্ত
কিতকিত বিশ্বাস
ঋত্বিক বিশ্বাস
সিগন্যাল আছে খারাপ।
হ্যালো স্যার।
হ্যাঁ বলো।
স্যার আমার আমার নাম প্রেজেন্ট দিয়েছেন, মোহাম্মদ বশিরুল্লাহ মন্ডল।
মোহাম্মদ
বশিরুল্লাহ মন্ডল, আপনি যখন দেখেছেন আমার মাইক কাজ করছিল না।
দাঁড়া আরেকবার বলো নামটা।
মোহাম্মদ বশিরুল্লাহ মন্ডল।
আচ্ছা হ্যাঁ ঠিক আছে, হ্যাঁ দিয়ে দিয়েছি।
মন্ডল করছিস কেন?
বশিরুল্লাহ মন্ডল।
হ্যাঁ হ্যাঁ দিয়েছি গো।
ঠিক আছে স্যার, থ্যাংক ইউ স্যার।
আমি মোটামুটি যতজনকে পড়াতে পড়াতে খেয়ালও করেছি, নাম খেয়াল রয়েছে, আমি সেটা তো খেয়াল রেখেইছি, অনেকটা মিস করে যাচ্ছিলাম, সামনে দেখতে পাচ্ছি না সবাইকে।
ঠিক আছে স্যার।
ঠিক আছে that is better.
চ্যাট বক্সে 2-3 জন লিখেছে, ওটা মাইক কাজ করছেন।
আচ্ছা দাঁড়াও, কে লিখছে? সোহাম ঋষি আর মাসুদ করিম। দাঁড়াও, সোহাম ঋষি মাসুদ করিম, ঠিক আছে চলো ফাইন, আমি দুজনকে দিয়ে দিচ্ছি। থ্যাংক ইউ অল, সো উই আর গোয়িং টু মিট অন স্যাটারডে 10 AM.
থ্যাংক ইউ স্যার।
বাই।
থ্যাংক ইউ স্যার, থ্যাংক ইউ স্যার।
স্যার একবার সিলেবাসটা আপনি গ্রুপে দিয়ে দিতে পারবেন আর একবার?
হ্যাঁ দিয়ে দেবো।
ওকে স্যার।
ঠিক আছে।